Welcome to how to graph and analyze 3D graphs with the fx-CG100. In this video, we will demonstrate how to graph and analyze 3D lines and planes. To start, press Home and select 3D Graph. The display shows the Function tab, where the equations of 3D graphs can be entered. Select Graph 1 to display a pop-up showing the different types of equations that can be used. In this video, we will demonstrate using templates, so select the first option. Then select Line from the menu. This displays the 4 available templates. Select the Express Cartesian template to show the input screen. Enter the parameters, starting with the numerator values, rearranging carefully to enter the correct values 1 for y0 and -1 for the denominator b. Confirm the equation to store the line in function. To graph the line, press Right tab and Draw to show the default 3D axes. The plot of the line lies outside the existing settings, so the scales need to be changed. Press Tools and select View Window. Then set the X, Y and Z axes maximum to 15, one at a time, and then the minimum values to -15. The grid values specify the number of points plotted and does not need to be changed. Press Back to close the pop-up and return to Function. Then Right tab and Draw to show the line. Scroll to rotate the view vertically and horizontally. We can now add another line equation. To graph this line through a point in a given direction, left tab back to Function. Then select Graph 2. Select Template as before, and Line. Scroll to select Through Point format to show the input screen. Enter the parameters, starting with the point coordinates and then the direction vector. Then confirm to store. The equation of a line through 2 given points can also be drawn. Scroll down and select Graph 3. Then select Template and Line as before. Now select Line through 2 points. Enter the coordinates in the input template. Noting that it does not matter which point is entered first. Then confirm to store the line. The final form of a line that can be entered is the vector equation. Scroll to Graph 1 to overwrite the existing entry. Then press Tools and enter Equation. Select Templates and Line as before. Then select the vector equation to show the input template. Enter the parameters, starting with the position vector and then the direction vector. And confirm to store. At the moment, all 3 graphs are selected and will be drawn. To specify whether a highlighted graph will be drawn, press Tools and turn Select On or Off with OK. To draw all 3 graphs, press Right tab and Draw. We can now analyze the graphs to find the intersections and relationships. Press Tools and select Graph Solve. Then Intersection. There is no intersection between the first 2 lines, so Not Found is displayed. Page scroll to show further analysis. The intersection between lines 2 and 3 is found, with the decimal coordinates shown, and also the intersection between lines 1 and 3. For two lines that are considered the same, coincident will be displayed. To investigate the relationship between lines, press back to end the analysis. Then Tools and Graph Solve again. Now select Relationship. Lines 1 and 2 are skew, hence no intersection. As expected, the other lines' relationships are given as intersect. Orthogonal, parallel, and coincident relationships can also be found. Additional trace analysis of lines can move a point along a line to show coordinate values. Press back to finish the relationship analysis. And then Tools. Select Trace to place the cursor on the first line. Scroll to move along the line, or Page Scroll to move between lines. We can now move to the second type of 3D graph to be demonstrated, which is a plane. End the analysis with back and press left tab to return to function. We will now delete all the existing lines with all clear. Then confirm the deletion. Select Graph 1 and Templates, then select Plane and the Cartesian form. Enter the parameters in the input template, rearranging slightly if your equation equals a value. Then confirm to store. Sometimes planes are defined by 3 points that lie on the plane. To draw this plane, select Graph 2, then Templates and Plane as before. Now select Plane through 3 points. Enter the parameters as X, Y and Z coordinates for the points in any order. Then confirm to store. The final form of a plane that can be entered is the vector equation. Select Graph 3, Templates and Plane as before. Then select the vector equation and enter the parameters, starting with the position vector and then the 2 direction vectors. Then confirm to store. Right tab and Draw to show the 3 planes. Analysis of planes is as for lines, finding relationships and intersections. Press Tools and Graph Solve. Then select Intersection to show the parametric equation of the line of intersection between planes 1 and 2. Page Scroll for the intersection between planes 2 and 3. Not Found is shown for planes 1 and 3, indicating no intersection. To view the relationships, press back to end the analysis. Then Tools and Graph Solve again. Then select Relationship. Planes 1 and 2 are orthogonal, as are planes 2 and 3. And planes 1 and 3 are parallel, hence no intersection. Other plane relationships that can be found are intersect and coincident. A combination of lines and planes can also be graphed and analysed. Press back and left tab to enter a new line. Delete Graph 3 by pressing Delete and confirming. Select Graph 3, Templates, Line and Vector Equation. Enter the parameters as before, starting with the position vector and then the direction vector. And confirm. To analyse the lines and planes together, press Right tab and Draw. Then Tools, Graph Solve and relationship. Planes 1 and 2 are orthogonal as before. Page scroll to see that the line lies on plane 2 and is orthogonal to plane 1 as expected. Other line-to-plane relationships are intersect and parallel. Now press back to complete analysing the graphs. Press Tools and Graph Solve, then Intersection. The line and plane 2 are coincident as the line lies on the plane. Page scroll to find the intersection point with plane 1. Parallel line and plane would show not found. We hope that you have found this video useful. If so, please do check out our other resources on the Casio Education UK website and YouTube.